Hi, welcome to Data Structure and Algorithm course, an offering by Cloney. In this course, we'll cover various topics like first we'll understand about what exactly is data structure and algorithm in a very brief overview, and then we'll cover about a concept in algorithm analysis called big O notation. What exactly is this? Then we'll move on to our first important data structure called stack. We'll see some exercises in stack. Then we'll discuss about queue. We'll see some exercises and assignments in queue. We'll discuss about linked list, exercises in linked list, tree data structure. We'll see the three different type of tree traversal. Then we'll move to binary search tree, a very important tree algorithm. And we'll see some of the assignments in binary search tree. After that, we'll start to the collection of sorting algorithms. One of them will be bubble sort. We'll start with bubble sort, the oldest one, although not used so much these days. Then we'll talk about selection sort. We'll discuss about what is insertion sort, merge sort, and then quick sort. Merge sort and quick sorts are the two sorting algorithms used most of the time in the software we develop. And we'll see some real world problems. So basically these are the topics which we'll cover in data structure and algorithm course. Now let us start with the basics of data structure, and we'll also talk about algorithm in a while. So start with the data structure. So what exactly is a data structure? What do you mean by data structure? A data structure is a particular way of storing and organizing data in a computer so that it can be used efficiently. Now, data structure is nothing very different than this simple concept. The data can be of different type and the storage need to be of different type. So if you remember, there are let us assume that you have different types of boxes. You have one cylindrical rectangle box like this. This is like this. And then you have a box, a square box, okay, which looks like this. Okay. Now there is a spherical box or circle. Now, depending on what kind of a material you are storing, one might be good, other might not be good. So if it is a square shape of plates, this might be good. If it is a liquid kind of a thing, you might want to store here, or a balls or something like that here, or circular plate. If it is like a cork or shuttle, you might want to put it here. Have you seen the CD, the way we keep the CD, or the CD which we use? So what is exactly these things? This is one kind of a storage, this is another kind of a storage, this is another kind of a storage, and this is another kind of a storage. So they are different way of storing some objects. So data structure is just like that. there are various ways to store the information, and that the way you store kind of in some cases works better than in other cases. And that's what we'll see, that if you store the data in this structure, it is faster for this case. If you store the data in, let us assume, stack. If you store the data in a stack for a particular kind of a behavior and aspect, it is faster. If you store the data in a tree for a sum of the functions, it is very good. If you store the data in a queue kind of a data structure, then it is differently good for some other situations and behavior. So data structure is nothing but a particular way of storing and organizing data in a computer science world so that it can be used efficiently. So that's all the data structure means. In other words, we can also say data structure is nothing but we get to know the knowledge about the relationship between data items allows designing of efficient algorithms for the manipulation of data. So this is very important, right? Knowledge about the relationship between data items allows us designing of efficient algorithms for the manipulation of data. So if we know that how the data items are related to each other or store each other, or how the search, edit or modify actions take place on those data items, if we know that, then we might be able to devise or develop a better algorithm. So it is very important that we know how the data is stored in a particular data structure. Okay. What are the various kinds of data structure in today's world? Some of the data structure which we know of are standard arrays, we know it. Linked list is one of the most important and widely used data structure. We also use the queue data structure, the stack data structure, a tree data structure. Binary search tree is one of the most widely used again for searching functions. And then we have a graph theory, where we talk about cyclic graph, uncyclic graph, directed graph, undirected graph, and those things. Although we are not going to cover graph in this course, that is little advanced, but we will be covering about arrays, linked lists, queues, stack and trees, and binary search tree. So those are the topics we will cover in this one. Now, what is the philosophy behind storing all of this data structure? The philosophy is that each data structure has some costs and benefits. What you have to understand is that in which data structure is useful for which scenario. Rarely is one data structure better than another in all situations. So you won't find that linked list is good for all the cases, or you will not find that tree data structure is suitable for every situation, or array is good for all the times. So one of these data structure might be good in one situation, another data structure might be good in another situation. So it is up to the data structure to data structure. What is common in each of these data structure is that a data structure, each of them will require a space to store each of the data items, and it will take some time to perform each basic operation. Basic operation means read, write and modify. You want to read, you want to delete, you want to insert, you want to modify. Whatever you want to do, these are the basic operations, and there is some time involved. So particular data might be good for read, other might be good for delete, other might be good for insert. Some of them might be good for modify faster in terms of speed and space, that is time and space. A solution is said to be efficient. Solution means that algorithm or the step to perform the basic operation. A solution is said to be efficient if it solves the problem within its resource constraint called space and time. So as we know that neither space nor time is unlimited. So depending on how you save the space and time, how efficiently you use them, a solution can be said efficient or inefficient. Only after a careful analysis of problem characteristic can we know the best data structure for the task. So whenever you have a requirement that which data structure you need to use, you need to analyze the situation in terms of what are the various operations that will be performed on that data structure. If you do not know the behavior or the actions which is going to be performed on a data structure, it is very difficult to design a efficient data structure for your requirement. Now let us understand a concept called abstract data type. What abstract data type means is that it is just a definition for a data type solely in terms of how the data would be stored and what would be the relationship among the various data. So it is like a high level declaration, leaving the implementation, low level implementation detail to the implementation classes. So it is just a very high level of thing. In ADT, there is no real implementation of storing the data like set interface, list interface, and map interface. So one of the example of abstract data type is set interface, list interface, and map interface. In abstract data type, there is never a real implementation. The real implementation happen in the real implementation classes. Okay, like hash map. For map, there is a hash map as a real implementation. For list interface, there is a linked list class as a real implementation. Okay. For set, there will be a tree set. So those are the implementation classes which are real classes which has a real logic of how to store the data and how to perform those basic operations on those data which is stored in the structure. Each ADT operation is defined by its input and outputs. In Java, we do this by declaring a method in interface or abstract class. Okay.